So in this question, there was a wood, and it's a cubical wood, and its mass, its mass, I'm assuming m. Its dimension, since it is a cube, I'm assuming it to be a cross a cross a, meaning every dimension is a. And there is a wood placed upon that. There is a mass placed upon that point mass, and that point mass is 200 gram. So in the question, if I remove this mass, point mass above the wood, of the cubical wood, the wood will be going up, and the rise in the level of this wood is given 2 centimeter. That's the thing they have given it. So the thing is, if I remove this, this structure converts into this structure. This is the state 1 and this is the state 2. The wood goes up. Okay. So to solve this question, so what is happening here? So when this point mass is placed onto the wood, then if you talk about the forces, there is a mg acting onto the wood, and there is one mg 200 gram corresponding to m dash g, which is coming because of this point mass. So there are 2 mg's which are coming onto this, and there is one buoyant force. So if I make the equation for this, let's make the equation FBD. So FBD I'm making, and I'm making for state 1 in equilibrium. So there is this mg which is corresponding to the cubical block. There is this m dash g, or we can say 0.2 g, which is coming because of the point mass 0.2 kg, and there is this fp 1, because this fb is coming because of the displaced liquid here. In the second case it will be different, and the acceleration is 0, obviously, because the system is in equilibrium. So if I make the equation here, mg plus 0.2 g will be equals to fb1. That is my equation 1. In the second case, this system, I'm removing this 200 gram, and because the removal of 200 gram, the liquid is going up. So when the liquid, when the body is going up, the displaced volume of liquid, if we see, so in this case, this is the displaced volume, and in this case, this is the displaced volume. So you see, in the first case, the block is displacing more volume, and in the second case, block is displacing the less volume. So let's make the FBD for 2. So there is this mg, there is no 0.2 mg, and there is this FB2, and the acceleration is again 0. So mg will be equals to FB2. Since I have to calculate the value of m here, so the value of m here will be equals to FB1 minus FB2. So in the first case, if you see these two cases, here it is going up. If it is going up, in this case, there is a reduction of buoyant force, and that reduction of buoyant force will be accounting for this mg. So let's assume this dimension to be x. So in this case, the dimension will become x minus 0.02. So here FB1, if you write the FB1 value of FB1 will be equals to a square, which is the cross section area, which is not changing in both the cases, multiplied with x, multiplied with density of liquid, and multiplied with g. And the FB2, if you write, that will be equals to, because cross section area is not changing, it is a square multiplied with x minus 0.02 multiplied with rho L into g. So if I subtract these cases, so if I subtract these two cases, because first I have to calculate the value of x. So if I subtract these cases, equation 1 minus equation 2, if I do, then it will be 0.02, it's not 0.02, it is 0.2. 0.2 g is equals to FB1 minus FB2. Or you put the value of g, or FB1 minus FB2. If I do that, FB1 minus FB2, if I do that, it will be equals to a square multiplied with 0.02 multiplied with rho L into g. See here, they are asking about the dimension of the cube, which is the a. And here if you see, I know the value of rho L, that is 10 to the power 3 kg per meter cube. We know the G, and G is getting cancelled. So if you solve this equation by putting the value of rho L and the value of G, and then you solve the equation, the value of A comes out to be 10 centimeter.